Catherine Clayton, and I want to talk to you about technology called particle diffusometry, which has been used to successfully characterize biopharmaceutical viscosity. And so, in the biopharmaceutical industry, they're often looking at new ways to look at viscosity-based measurements. This helps with scaling up manufacturing, as well as later for producing drugs that lower patient pain by making something more syringeable. So, the one issue that's out there is that current methods to look at viscosity are low throughput and they use a lot of sample volume. When you're using a lot of sample volume, this isn't good for when you're doing a lot of development of drugs. Later down the line, if you're doing low throughput measurement systems, this takes a lot of time and a lot of money to do if you're only able to analyze one thing at a time. So there's a need to have something that uses very low volumes, and that is high throughput. And so we have a solution called particle diffusometry. It's an optical-based method that can be used to look at the viscosity of protein-based solution as a function of their concentration, as a function of their degradation, and their formulation. And the way in which it works is that you take this biopharmaceutical solution, you add particles to it, and you image it. And using proprietary-based algorithms, you can extract out this viscosity information. And so, if we look at this plot up here, one example of doing this was with antibodies. Antibodies are often used in cancer-based therapies. And we looked at a variety of concentrations, and we're able to pull out this viscosity information from anywhere from 0 to 50 milligrams per milliliter with statistical significance. So the competitive edge of using this technique is that first, there's these proprietary algorithms that remain within the Kinzer, Ursum, and Worley lab within the School of Engineering. It uses less than 5 microliters of sample, which is better than the techniques out there that use 60 microliters to 10 milliliters of sample. Also, these measurement times are 8 seconds as opposed to hours or running them overnight. The optics are simple as well as the setup, and it can be used for a wide variety of protein-based pharmaceuticals, from antibodies to insulin. So what we see for the future is providing a benchtop-based system that would be in a 96-well plate format for a high-throughput measurement of biopharmaceutical viscosity. And so from this, we'd like to talk to people in industry to assess the needs for a high-throughput system as well as collaboration.